Yeah, I think what we're going to be doing, there was previously a ARC webinar, and what we're going to be presenting is just, updates to where ARC is at since the few months when it was last presented. Is that right, Dagan?
Yeah, pretty much. This is much more back and forth in a presentation. Like I think the last ARC sort of update we had was much more like a lecture than anything else, and that's not the intention here. The intention here is just to say, we have launched officially in production now. We are expecting that people will want to switch their applications to use ARC, and they can be assured that it's pretty stable, and certainly in comparison to where we were at. Like, I think it's been a year now. So I think things are significantly more stable now. We have a testing CLI that's deployable from the code base itself that will sort of replicate the kind of test that David Case was doing. I mean, a different approach, but we're trying to do that more frequently than we would want to ask Dave to be perpetually just testing ARC, which I'm sure he appreciates not having to do that all the time, because it can't be that interesting. But sort of scaling tests we're doing more on the regular, and we needed to get above a certain amount to consider it pretty much stable for production. What we were really keen to do is not have it be the bottleneck of the network in future, because I think in the past it's fair to say that MAPI kind of was, in that it puts all this load on this one node somewhere at the center of the network, and once there's a lot of traffic coming in, it starts to ignore JSON RPC requests. They just hang. We get 500 errors, and then that's when people start getting calls asking why. So ARC is definitely at that stage now where it's, Tal run it in a Kubernetes cluster with an auto-scaling group, so it can pretty much scale out to, hopefully ahead of real use, so that we're never running into scalability issues. So as long as the spike isn't too dramatic, it's pretty much ready for anything, and it will scale up accordingly. So that's probably the biggest change. I'd say there's another element to it is the response granularity is a little bit more simplified than we were first imagining. But these days, I think it's about 4 different statuses you can get back. And there has been some discussion here on the Discord. I don't know if Curtis is here. I don't know what Curtis's monikers are, so maybe Curtis is one of you guys. But from Tokenized, he was giving us some really great feedback and just asking some questions about, like, how is a client supposed to work with this stuff. So hopefully this conversation can answer some of those questions, or perhaps different ones that some of you guys might have. So I'm kind of hoping that there will be more questions that I can answer more than just a lecture today.
I don't think Curtis is on. He has his name in his handle. He was on before when we were trying the other area, and I think the tech problems. So it might be worth mentioning him and pulling him on to get his feedback.
Definitely. I want to see if I can just find his feedback. If no one has any questions, I'm just going to read out Curtis's messages and perhaps address some of those points. Are we recording this, Brett, or is it?
Yes, this is being recorded.
Okay, perfect. Then I can answer Curtis's questions, and hopefully he can still benefit from them, even though he may not be available just now. So basically, his concerns. He had some concerns, and I want to make sure I sort of steelman his case. So he was asking specifically about a couple of responses ARC gives, so the API specifically. One of them is accepted by network as a status, and another one is seen on network. And here's what he said. The main reason for wanting accepted by network status is that it means the TX is accepted by that miner specifically, and that acceptance is backed by the history of proof of work of that miner, meaning the miner operating that ARC instance let's put it in their candidate block. The way I understand it, seen on network just means some basically anonymous nodes with no link to proof of work have accepted it. You can't trust nodes without proof of work. They can be Sybiled. And I definitely agree with those sentiments. I wanted to give some perspective on a couple of the, seen on network specifically as a response. So in my mind, seen on network really comes after the sort of miner who first received the transaction has already broadcasted it. So I guess the idea being that, well, first of all, if you're speaking to Tal's instance of Arc, their instance is indeed tied to nodes that are well, I mean, they are a miner, so they have proof of work behind them. But the idea is that if you get a response seen on network, it means that not only has it passed validation at Arc and has been sent to the corresponding nodes of the peer-to-peer network, but it's also been seen on network in terms of they are now announcing it. The nodes that the Arc instance is connecting to are now announcing it as valid, which means they have done their validation steps, which means it is in their candidate block as well. So because Arc instances that are associated with Tal are associated with mining nodes, that's how we can we sort of do have the information that Curtis is looking for in terms of, yes, it's in the candidate block of someone with some proof of work. Although since he's not here, it's kind of hard to continue that debate. But yeah, are there any thoughts on that front in terms of, is this unclear from the documentation on anyone else's sort of understanding of how these things work? All pretty clear.
Just looking through the documentation right now. You had mentioned there's 4 states. Is that right, or are there?
Yeah, so I realized there are significantly more states that are mentioned in the documentation, and those were the original ones that were available. So I guess the ones that you can expect to actually see, unless you specify them explicitly. So I just want to say that basically they've reduced the number of sort of updates to the status because basically they happen so quickly that it doesn't make sense to update the database that quickly. Unless you're specifically looking for one status, in which case you can put that into the X wait for status header so that you'll get a response when it hits that sort of point in the propagation cycle. So I just want to be clear about which 4 I'm referring to there. Let me just bring up our internal dev chat to make sure. I validated this with Michael, who I hoped would join us today. I don't know if he's available anymore. That doesn't look like it. Okay. So one thing that's kind of changed as part of this in terms of the statuses is that callbacker was a whole separate service. It was kind of a microservice that was separated out. And these days, it actually came as a surprise to me looking back on things. It was actually effectively rolled into Metamorph. So sending callbacks is now part of Metamorph. Metamorph being the microservice that's responsible for kind of listening to the P2P network and updating storing the transaction, updating its status with respect to the messages that are heard on the P2P network and elsewhere. In terms of ZMQ as well. So still searching around for my message here in terms of the exact statuses. I think seen in orphan mempool is one of them. Yeah, so full status updates. We'll just get you these 4. So it'll get you seen on network. It will get you seen in orphan mempool. It will get you rejected, and it will get you mined. If you don't set the header for full status updates, which is just X full status updates, you will get the default, which is it will only give you callbacks when the transaction is rejected. when the transaction is mined. So that's the sort of default behavior. So if you want that early seen on network callback separate from just the response to the original post, which you will receive a response to, obviously, normally. If you want that as a callback, in other words, if you have some separate system that's tracking that stuff rather than just a response to that original request, then you should set X full status updates. That's how you would do that. But yeah, those are the 4 I was referring to be specific.
Okay. Anything else from you on that topic, Crambo, or anyone else on the explanation there? Otherwise, we did have some questions from BC as well.
No, I'm good. Thanks, John.
Yeah, pleasure.
My question is now a good time.
Yeah, feel free. Your voice is a little low, but feel free to share that question.
Sure, I'll try to speak a little louder. Hi, guys. My name's Phil, and I apologize. I have not been following this ARC progress, or only skimmed the documentation a while back. So I'm fairly ignorant, and so I apologize if high level. But so right now I'm building using what's on chain and BitTails, and I don't know where they're going in the future, if they're using ARC. Can anyone speak to that? I guess my question is, of course, no one has a crystal ball, but at what point will I need to use ARC? I guess.
Right. Valid question. Yeah. Yeah, so we're in very close conversation with Watson Chain, and we've had a couple of conversations with the BitTails guys as well. So from my perspective, I don't see either of them as using ARC necessarily. ARC is predominantly built as something that you can use to write transactions to chain, rather than for sort of reading them back or indexing them anyway. It's really just it's trying to turn what is a sort of fuzzy problem of attempting to make sure all of the nodes on a peer-to-peer network hear about your transaction. It's trying to turn that into more of like a web API. So it's like just a simple submit and forget situation. That's the ideal. That's what we're aiming for. Submit and forget, and get a call back with the Merkle path once it's mined. That's the ideal we're aiming for.
Thank you. So at what point would I be turned? I guess, is there going to be potentially a point where what's on chain and BitTails break down where they don't successfully broadcast what I'm asking to broadcast from using your API? Blocks are too big, or?
Look, I certainly hope not. There are teams of engineers working for both of those, the development of both of those products, and I hope that they wouldn't break down. And I'm not necessarily even saying that they will. I should say that the motivation for something like ARC is an attempt to try and guide application developers into the direction of adopting an SPV first approach to application architecture. So to break that thought down, ARC introduced extended format transactions. So the extended part of transactions in the serialized data is the previous transaction, sometimes referred to as parent transactions or source transactions, the transactions from which you are spending outputs in your sort of current one. The locking script and Satoshi amounts of those inputs are included in the data with extended format transactions. So the reason the engineers that first developed ARC did that is because in order to validate these sort of locking scripts and fee being paid by a transaction, you need that data at minimum. And it's also data that's readily available to anyone who's signing a transaction, because it's part of the digest that becomes the pre-image that gets signed with ECDSA. So it seemed like an easy win to sort of pass this data to the API, which was then going to validate it before propagating it to the P2P network. And that was a way, the thinking was that if you propagate an invalid transaction, then the default behavior would be to ban the peer that sent the invalid transaction because it's trying to scam someone or whatever. So the original thinking was these ARC instances could be run by anyone, and as a protection to getting banned as a service operator, you would want to make sure that the transactions you're receiving were valid before you broadcasted them. And the only way to do that is to check that extended format data. So like I said, so the purpose is to guide people in the direction of using extended format and getting used to the idea that you might need to provide more than the minimum data to transaction processors in future. Now, this holds with Terranode in that the Terranode sort of internal transaction format for its validators and so on is extended format. You know, some of the same engineers are working on Terranode that worked on the original ARC code. So if you imagine Terranode is expecting extended format transactions to be able to quickly to be able to horizontally scale the ingest of massive amounts of transactions, you can imagine that it's going to be a lot easier for overlay services and anyone that is handing transactions to the network. It's going to be a lot easier if they already have that data. So if you, as a receiver of transactions from counterparties, now need extended format in order to broadcast via ARC, then you're going to have to start asking the originator of those transactions for that data. So again, the idea is to encourage more and more adoption of what is essentially SPV. So over the last 2 years, I have been a proponent of SPV, and I've been trying to set standards for how we might encode the data needed for full SPV. So that is the EF data, but even further extended. So we've been referring to it as BEEF, which is for background evaluation extended format. So the idea being that you don't just have the locking scripts and Satoshi value of the source transactions, but you actually have the full source transaction. And you also have the Merkle path for that full source transaction. So now we have a way to pass Merkle paths and full transaction data and ancestry between peers. And the idea there being that you can do things like offline validation and things like that in the mindset of SPV, where you're really trusting the chain of signatures more than settlement on chain. So that's the idea, allowing that sort of thing, encouraging application developers to start thinking about the data they need to be able to validate things without a third party, and then encouraging us all towards using those formats for broadcast purposes as well. So ARC is just sort of like the starting point for encouraging that. I think your original question, I've ranted for a little bit. Your original question was, when am I going to need to use ARC because everything else is failing? That's just something you could speculate about. I think it's fair to say there's very competent engineers working on Watson Chain and BitTails. They will likely figure out how to scale things as and when needed. And certainly the attitude of those engineers is that, like, guys, we're talking about 1 million transactions per second here. That's not coming for years and years in terms of mainnet. Certainly, I've heard that perspective a lot over the last 2 years. So that's a reasonable opinion. And I would say that my job is to try and convince people to adopt principles that will scale to 1 million transactions per second now, so that they don't have to when everything is on fire, when it actually happens in the real world. So I'm trying to encourage the SPV adoption of SPV now, and adoption of ARC now, so that when Terranode comes along and suddenly we're able to do a huge throughput of transactions per second, it doesn't just sort of kill all of the various services that people rely on today, and then we're all sort of staring at each other, wondering what to do. So hopefully I'm giving a solution to the potential for there to be massive amounts of transactions now, and how you can avoid the bottlenecks of various services in the ecosystem if they come up. Maybe they'll never come up. Maybe you'll never have to use Arc. But I'm certainly trying to help the ecosystem come together and provide these services for if that happens.
Thank you. That sounds good. So it sounds like, depending on a given application, I may, someone might be building, they may or may not need to use Arc. If they're using another service that's Arc friendly or Arc aware or Arc client or users Arc or whatever, then it's conceivable that I don't need to know a whole lot about Arc other than just being aware of what's coming down the pike, where maybe it's a good idea when I'm presenting transactions to present it in the extended format.
Yeah, exactly. So if you don't have a way to encode extended format now, I guess I would just say that once Terranode is like the only node operating, and I suspect that would be a pretty quick transition once it's actually in production for a decent amount of time and takes on the role that SV node is providing for us just now. Once that's in production, I would imagine that it's going to be a little bit more difficult to submit non-extended format transactions. But I'm vaguely aware of them trying to make sure that they don't break the entire ecosystem. So if it is the case that actually nobody's ready for it, I suspect there will be some way to sort of translate, if that makes sense. I mean, there's a translation service at ef.o with an umlaut.network. That's a horrible URL to say, and I realize. But there are little sort of mini APIs that you can use to translate these things, as well as libraries these days to translate into EF, if you have all of the required transactions, of course. If you receive a raw transaction from a counterparty, there's nothing you can really do to, well, you could look up what's on chain to get the parent transactions and form your own EF. So that's the sort of thing I'd imagine people will do if they're not quite ready to submit EF themselves.
All right, we did have Curtis rejoin our chat. Curtis, sorry about the audio issues before, but yeah, Darren, specifically, you brought up your questions and thanked you for those questions before. Dagan, did you want to maybe comment on that at all now that Curtis is here?
Yeah, absolutely. So, I mean, first of all, thanks for all the attention you've been giving Arc and scrutiny of it. That's the best way to make sure these services are doing what they need to do for engineers of the ecosystem. So I appreciate your comments, and I don't know if you want to restate your own question. I tried to read some of your comments previously, but maybe you have new thoughts since.
No, I mean, I appreciate you looking at all the feedback, and yeah, I think it's the best way to figure out how to solve things is to propose things and then discuss them. So yeah, I don't think I really have anything new specifically. Just kind of, in general, it's the one concern is I think people will need to know about potential double spends. Like merchants and stuff, when they're accepting, if they want to do, like zero conf, then they want to know if there's another transaction out there that is attempting to double spend against the transaction that's paying them. And I also think that we kind of want to, I think the point of it is that we want the users to talk to the miners, because like the peer-to-peer network is designed for miners to talk to each other, and so it's not really the best place for like users to get in there to talk to them. So we want a protocol that is for users to talk to miners, which is basically to submit transactions to them and get statuses back. And in that scenario, the users only care about proof of work. Like they don't want to know if other nodes, if random anonymous nodes on the network are accepting their transaction. They want to know if the miner accepted their transaction. And so I think we want to have like a key structure in there somewhere where the miners are signing these responses, so you know that that miner accepted that transaction. And even potentially you can prove it later. You can say, hey, this miner accepted this transaction and then later didn't mine it, so you know there's might be
it
some
screwed up
issue
my
there.
system somehow. Yeah, it's a great point. It's a great point, and I think that it probably raises its head. Both of your points there raise a couple of flags, because you're coming from a world where Mappy was solving these problems for you, and then all of a sudden we bust in and we're like, actually, we're going to ruin everything you've been using, which I appreciate is incredibly annoying. There's some element of it that is in preparation for, in fact, I would say almost all of Arc's purposes in preparation of Terranode adoption. And I should say that there's no sort of, I don't know if there is any sort of official documentation of exactly how Terranode's going to ingest transactions, and it's a subject of discussion internally at BSVA at the moment in terms of what language we use to describe these things. You've heard Jake talk about, Jake Jones, talk about IPv6 multicast and how that might help us in terms of reaching optimal efficiency with respect to transaction propagation. So, for example, there may be some service that runs that receives a transaction that then gets sort of routed via IPv6 multicast to every Terranode instance that's connected, and it's a sort of pub sub model. So that means that they don't have to send to one peer and then the other peer and then the other peer and form this complicated peer-to-peer network. Rather, they have some sort of rendezvous point at the network level that distributes all of the packets to the correct servers and services and so on. So because of that, I think that the approach is more like submit to Arc, and it's considered that you are really submitting to all miners rather than just one specific one. And certainly I remember that in the original Bucks code that has since become SPV Wallet, there was an option to sort of submit transactions to many Mappy instances. So like back in the day, it was Tal, it was Gorilla Pool, it was Mempool, it was Matterpool. Like there was a bunch of people running Mappy instances, and all of them were running nodes, and not all of them had proof of work behind them, but most of them had at least a little bit. So the idea was that you would kind of have an array of Mappy instances that you were broadcasting to, and then they'd each sign just like you're suggesting. But then you'd have different competing signatures, and maybe it was possible still to have errors at that point, depending on who won that particular block. Now we're in a slightly different situation, just because Tal is so dominant that I think for the most part, you want to really just broadcast to the most dominant miners, I think is what you're saying, if I understand you correctly. Basically, you want to make sure that Tal has your transaction. So,
well, in some sense, you want to make sure they all do, because there's always a chance that another miner gets a block, and and if they didn't agree with your transaction, then then it causes more problems.
Yeah, definitely. So I found out during development of Arc, we were looking deeply into the P2P message formats, and my understanding is there is actually a P2P message which is like an explicit reject. So it should hypothetically be the case that you submit this transaction to Arc, it propagates it on the peer-to-peer network, and it should give you a reject message, even over peer-to-peer, not necessarily just ZMQ. If you're actually in the same sort of cluster or whatever as a node, but actually, even if you were just some random person running an Arc instance, hypothetically, you should get reject messages if there's some sort of actual problem. I think where we've actually seen in the real world some issues. Maybe I'll detail some of the real world issues we've had with Arc. So through testing, we came to some realizations about having to scale things out horizontally and scaling out the different microservices differently, and so on and so forth. Also having a database that was I believe Tal, I was hoping Michael would join so he could give you some more of these details. I don't see Tal's instance. I'm just responsible for the open source stuff. So unfortunately, I don't actually see the instance that most people use. But obviously, we speak all the time with the guys at Tal who do have access. So my understanding is that there were some issues early on with things like database lockup, multiple instances of a metamorph trying to access the same database and it not being sort of ready for that kind of thing. So a lot of the work that they've done on it since a year ago is associated with that. Some of the code I contributed was things like making sure the block TX service, which calculates Merkle paths for all the transactions in a block, was like super inefficient. And that's just because, I mean, the original code was just complex. It was looping through things twice unnecessarily. It was just kind of trying to put stuff together that shipped really quickly rather than thinking about the efficiency of the code and its performance metrics and things. And once they started building performance metrics in, you could just immediately see that, oh, this was like a massive performance lag. Whenever a block was mined, it was taking like hours to calculate the Merkle paths for all the transactions. So thankfully that stuff has all been solved and block TX is all really efficient now. But some of the other feedback we got was from the guys at Handcache, who are super helpful in just absolutely obliterating us in terms of just saying this is an absolute pile of garbage. And you know, sometimes you need harsh feedback to push development forward, and that's certainly what we got from those guys. But to go into the details of some of the things that were causing issues, so for example, there was a 0 fee transaction that came into Handcache's systems. I don't know if I'm even allowed to say this, come to think of it. Let's just say, hypothetically, there's a company out there that received a 0 fee transaction and broadcasted that to Arc. So let's talk about it in the abstract. I don't want to, you know. So Arc doesn't know that the transaction was 0 fee, or rather, it does. Sorry, Arc does know if there's extended format, it can tell that the transaction had 0 fee. But what it can't do is tell that a parent transaction was 0 fee. So imagine that somebody broadcasts a transaction with 0 fee, which basically is you know, something you can only really do through direct peer-to-peer announcement. To say that it's in somebody's secondary mempool, they don't necessarily intend to mine it, but it is a valid transaction. Now you create a child of that transaction, i.e. something that spends the UTXO created by the 0 fee transaction, and that does pay fees. Now you can send that transaction to Arc. It will pass validation because it pays fees. The scripts are all valid, and it doesn't get rejected because the UTXO does exist. It's just in the secondary mempool of most miners. So they never intended to mine it, but it was a valid transaction. That sets up like a really weird response from Arc. You get seen in orphan mempool, something like that. So, or it might actually even come back as like valid, because it is. So this is the point we're at now. And so I wanted to talk about it because this problem has a solution, and the solution is SPV. So the idea is that you don't have a Merkle path for the 0 fee transaction because nobody has mined it because they don't want to, because there's no fees on it. So what this does, if you imagine, rather than this transaction coming into company X's servers and being considered valid, if you have to include the Merkle path for the transaction involved and you don't have it, with beef format, you would have to then get the parent of it and keep going back through history until you arrive at a point where every input has either a Merkle path or a parent associated with it. So everything is anchored, everything is like guaranteed on chain. And then you send that whole data structure to, let's just say Arc. We just send that to Arc. So now Arc is able to evaluate the entire history of this chain of digital signatures and validate everything. So maybe it is still valid, but now it sees that, hey, one of these transactions in the sort of history is not paying any fees. So it knows at that point that it is very unlikely that that transaction is actually going to be mined, and therefore there's a broken chain in this chain of otherwise valid transactions. So then we have an API that can actually reject those transactions, at least until maybe someone is solo mining and maybe they set their own node to mine the zero fee transaction. And so it eventually gets mined. And from that point onward, you can update the beef structure so that the Merkle path for the zero fee transaction is included and submit the same otherwise a set of transactions to Arc again. And it will evaluate it again. And it will see that although this transaction has zero fees, it has been confirmed in a block. So that doesn't matter anymore. And so then the transaction can be accepted and will be propagated to the rest of the nodes.
Yeah. And that's kind of my point with the like accepted by network status is I believe my understanding of accepted by network is that it basically means that transaction is in the candidate block for that miner. And so that would mean like if there is like something weird in the history, like a zero fee, then that means that miner is still planning on including its entire ancestry in that block and mining that transaction.
Right.
It doesn't just mean that that node says that transaction is technically valid. It means
right.
it's valid and I want to mine it. Yeah.
And they want to mine it. Right. Gotcha.
Because I think there will be, especially in the future, there will be a lot of like special criteria, you know, like an output is frozen or something, or there's certain criteria for paying lower fees versus higher fees, or there's, you know, I'm sure there's a bunch of different criteria that we'll be able to come up with where some miners maybe won't want to mine something, but then some might, or there'll just be a lot of rules that the users won't really want to care about. They'll just want to know, is this transaction going to be included in a block? And so that's what they call ARC for. And then, you know, whether that's talking to many miners at once or however it works, but they can get like actual statuses from the miners saying, yeah, this transaction's good. We're going to mine this transaction.
Yes, right. So my understanding of, and maybe they're not perfectly worded either, the status update. So accepted by network, we're talking about a status ID of, what is it now? 8, I think. Where CNO network is 9. So that leads me to believe that CNO network is supposed to come after accepted by network. So I think, so part of this question is like, why is CNO network like a default if you ask for what is it, full callbacks? I can't remember the phraseology used in the header, but basically you want as much information about callbacks as possible. The reason CNO network is used is because my understanding is that accepted by network basically just means that the node that you're connected to, which in Tal's case is a mining node, so the Arc itself is not a node, right? The Arc is connected to the peer-to-peer network, and the default configuration for miners that are running Arc is to connect to your own mining node. So, and Tal have a number of mining nodes, but let's just say one of the mining nodes. So when it's the status accepted by network, I believe, is when that mining node says, please give me the transaction data, and I think that
it says it's triggered by the ZMQ from the mining node. So it's some specific status in ZMQ that feeds a message back that says that it's reached that state in the actual mining software.
Yeah, my mistake. So what I'm trying to talk about is CNON network in that case. So the idea being that CNON network is the status when you hear that the connected node of the peer-to-peer is basically announcing the same TX ID. And it would only announce the same TX ID if it had validated the transaction. It validates the transaction, and then it says,
yeah. So it says it's technically valid, but it doesn't mean they're gonna mine it, because we still want to, like, there was a whole phase where we wanted to propagate all the transactions so that everybody can see double spend attempts and everything like that. So you're going to propagate transactions even if they're too low a fee, that you're not going to mine them, and or
right,
if they don't meet some other criteria where they're technically valid but not, you don't like that transaction still, so, or the miner doesn't like that transaction still, so they're still going to propagate them, but they're not going to mine them.
Right. Yeah, I'm with you.
Yeah, my impression is just that the CNON network just means that, like, the nodes it's propagating throughout the network, which is, it's a good status to know about, but it's not necessarily the status that that a lot of merchants would probably care about.
Gotcha. Okay, well, I'm glad we had this conversation because I actually understand what you're aiming at now. That's good.
Sometimes I'm not very clear, or sometimes I use the wrong terminology or something, so people don't know what I mean.
You're very humble. I think it's sometimes there are too many Slack messages to comprehend everything in text. So conversations like this are useful.
Yeah.
If there was a pause for an additional question, maybe I could
Yeah,
just
absolutely
step in. First of all, just reach out and ask David, do you have a microphone available by any chance?
Yes, I do.
All right. Well, I wanted to lead in with a question that I think relates to this topic that David brought up during the Script hackathon, which, Dagan, you weren't available. You weren't at that hackathon, but Jake, Jones, and Thomas were. But maybe I could just
to my regret.
Maybe I could just try to rephrase this question because I thought it was really insightful. So it was a question relating to the ability for a transaction to sort of get lost completely because some information, hopefully I'm jogging David's memory about this. David, do you know the question that I'm asking about? You asked it during that session on I believe the second day.
I believe I made some comments about historical performance, not so much current states of things.
Yeah, so. I mean, it sounds similar to the feedback we got from you when you were doing those tests for us, which really broke stuff a lot, which I appreciate because we were then able to come back. I think what you're referring to is when you were able to kill an ARC instance, it basically forgot all of the transactions you had sent it. Am I remembering correctly?
I think it had more to do with the fact that if you managed to kill it, anything that was mined in the time while it was disconnected from the network, it would never tell you about. So, and again,
right.
I know there's been optimizations to the callbacker and all that stuff. So these might all be resolved. But at that time, I know there was some things where definitely there was some state that kind of got knocked out of whack.
I totally agree. Yeah. We use the Elon Musk approach to optimization by deleting callbacker entirely. So it's just part of Metamorph now.
Yeah, but I guess still the case is probably involving does it actually go back? If something goes down, if there's a failure where it has lost communication with the network for some time, I believe anyways the issue was it didn't have any way at the time of catching back up. Essentially, the things that happened while it was dead just kind of never resolved themselves. There was never an outcome tracked.
Yeah, so my understanding is, yes, I believe that it now copes with catastrophic failures. My understanding is that the database that was being used is no longer being used, and now we're using some. Well, when I say we, Tal are using some sort of AWS database, which is much more sort of fault tolerant in that it stays up even if the instances that are communicating to it go down. So it will persist whatever the last status is and follow on from there. And if the callback URL is in the original request, so it always has that in order to respond to. But you're talking about if something gets mined, so that would be block TX. And I believe it would update the records in the database with the Merkle path. And if the metamorph was down, it's a good question. There was a queue introduced for this. I think it's solved, but it's something that I'll clarify with the team. I'm sure they'll be able to answer better than me, because I must admit, I believe it's solved, but I can't speak with authority on that. I would need to ask Michael.
Yeah, and I wasn't coming in like I haven't had any problems with Arc for a while. That was just something from our big old test.
Yeah, I believe so. Yeah, so I mean, so in terms of production stability and so on, I think it's fair enough to say that Handcash are now using it. They're using it for transactions that they produce, and they've been doing that for a long time. I believe that they still do not use it for transactions that they receive from counterparties because of the aforementioned sort of zero fee situation. I've heard no update to that effect since. But yeah, so Rock Wallet are now taking a look at things. So some key players are really taking a very serious look at it now, which is good, because a year ago everyone was just like not that interested. Maybe it was fair to say that the developers were quite interested in sort of trying out the newest thing, but most businesses were kind of a little wary of it at first, which is totally fair enough. I can say that all of the apps that I'm involved in, those have all been updated to use Arc these days.
Yeah, Tokenized is using it in our dev environment right now. We're just kind of making sure it's at least as reliable as Merchant API before we push it up to production. But yeah, it's working well so far. And we use it for transactions that we created and transactions that we see, because we still kind of scan the network for some transactions, and so we use it for those too, to try to double check that they are good transactions before we, kind of process them through and accept them as valid.
Awesome.
Well,
very good.
I had a business question that relates to Arc and could potentially relate to Tokenized as well. One of the things that I was wondering is, would it, especially now that the instances and the backups are running on really resilient networks like AWS, and part of the goal is to professionalize the services such that there's extreme level of robustness and reliability. I wondered if has there ever been any discussions around the concept of providing some sort of insurance, like ahead of time, to customers that get these callbacks from Arc, or these confirmations from Arc, such that maybe you're an exchange that's operating with SPV or something like this, and so you're getting a confirmation that something is a valid transaction, but even if it turned out that there was some sort of gap in that, and it turned out that it wasn't, that some like insurance that could protect the confirmation could exist. Have you ever thought about anything from a business logic sense about providing that through with Arc?
No. It's open source software, right? So what you're talking about is contract between operators and users. That's not, thankfully, it's not my decision. That's up to Tal. It's up to Gorilla It's up to anyone who wants to run an Arc instance independently to come up with the terms of a service level agreement they might have with their users. Yes, I think it's a fantastic idea, but it's not my choice. Sorry, go on, Curtius.
Yeah, I think just like just like any merchant, you have to accept a certain amount of risk with every transaction, and but there is, that kind of gets back to you want the miners to sign the responses that they give you, so that you know for sure that miner approved that transaction. So if anything is like happening maliciously on the back end, then you'll have some evidence that you can use to try to catch the people that are causing problems. But yeah, it goes back to the kind of one of the early ideas in zero conf is just that if it's a big transaction that's important, then wait for some confirmation so that you have some proof of work backing it up. And if you know
economic
that would
decision.
be similar to buying insurance. Like if you're going to buy insurance, you can just wait for some confirmations first.
Totally agree. Yeah, it's an economic security solution, right? Depends on how much you're concerned about. If it's a micro payment, then you absolutely can just accept zero conf without question. Absolutely. But if it's millions of dollars, obviously you can wait 10 minutes. The way you phrased that reminded me of why it might not be a good idea to have minor ID signatures. Because he said, we were discussing this morning, we had an update with the Terno guys, and we're discussing sort of overall architecture. And in fact, I tweeted the part of the document that we were discussing, which is just a picture of users writing to a business service, which writes to the blockchain, which gives a timestamp back, which allows users to read timestamped data back. So the idea being that, well, when you read data, it's not coming from the Terra nodes, and that if Terra nodes are expected to do 1 million transactions a second, they actually don't have time to sign every single sort of acceptance response. And what I mean by that is it makes things so much more expensive because ECDSA is not like a quick thing to do computationally if you're doing 1 million a second, you know. So the general principle is you submit transactions to a multicast group address for Terra nodes to then process it, and you expect basically nothing back other than a Merkle path. You're just going to get a Merkle path back. So long as everything's fine. And obviously it's going to be the case that if there are some sort of erroneous conditions or whatever, then Terra node is going to flag that as rejected. So it's an explicit rejection and an implicit acceptance. Something like that.
So in that flow though, you're saying you wouldn't get any statuses either?
Right.
Oh, okay.
Yeah. So
yeah,
I think it's
mean,
something that's super. Sorry, go on.
I was just gonna say, regarding like slowing down, you know, the Terra node transaction processing, block building, it can always be, you know, kind of an ancillary service that's got a trusted connection to the Terra node, and you know, and it can do all the signing in a, you know, completely different system, and it's just saying, you know, Terra node says this transaction's in the next block, and then sign it and send it back. But I do see your point where like if everybody is hitting
It's a lot of
every node
signatures
and trying to sign everything, you know, so everybody wants a signature for their transaction from every miner, then that could be a problem.
That could be a problem. But yeah, what you're saying makes some sense. One of the ideas discussed was that in the block assembler within Terranode, it is it kind of the terminology used. There's blessed transactions, which has basically been validated once already, so it never validates them again. It assembles those into subtrees, which are sort of, you know, something that looks like a Merkle tree, but is lower down in the overall Merkle tree of the block. But these things are produced once every 1 million transactions. So in Terranode's uptime or throughput, it would be 1 every second. So these subtrees are announced to all competitors so that they can validate their block, you know, very quickly because they've already validated the subtrees, and that makes, you know, the announcement of a block to everyone accepting it a very small amount of time. So that's advantageous to sort of front run the validation of the subtrees. So anyway, the point is subtrees are going to be announced, and so if they're announced,
and they're signed too, is my understanding.
Right. So at least you'll have a signature per 1 million transactions, which reduces the burden by 1 millionfold. So if it's announced in a subtree that's signed by a miner, then you can pretty much consider it sort of we're actively putting this into a block, and that's kind of hard to fake.
Yeah, there could be a service that gives you a sub-Merkle proof with that signature of the subtree.
Exactly what that's exactly what we're aiming to do. Yeah, just so we'd call it a partial path. up to the top of the subtree hash, and then we just add the top of the Merkle path once the block is announced. Yeah. Yeah. Yeah, so that will get you what you want, thankfully, and we've just got to deal with this sort of halfway house in the meantime, but hopefully it gets people thinking about, where we're moving.
Yeah, I like it all, and I don't want to sound like I'm trying to be negative towards ARC, because I think it is a step in the right direction. Like, especially the kind of more asynchronous nature of it. I think a lot of Bitcoin applications are built to be synchronous, where like you want to send a transaction and you want to wait for the status of that transaction before you perform the next action, and you know everybody wants to do everything in order. But the way that it should really work, I think, and the way a lot of, especially if you're thinking of the user interface, is the person wants to send that transaction, and then that might have to wait on another person approving something, or it could wait a whole bunch of different things. So then you just want to get notification back when it reaches the next stage of its process, and you don't want to like sit there and wait for it to get to the next stage.
Couldn't agree more. Yeah, we're using that same principle when it comes to development of the sort of mobile front end for the sort of SPV wallet stuff, to try and just test out some stuff which might be like commercially inviolable to test out. So we're trying to test out best practices in there, demonstrate how it might work, and then there might be commercial opportunities to then take that idea on and sell it to users or whatever. So things like solicited payments. We live in a world where it's all push. I choose to pay David Case whenever I want. I can send him some Satoshis and there's nothing you can do about it.
Yeah, that's one thing I don't like. I want to go away from those because they cause all kinds of other problems too. Because then you have to, like, if you're using a service that responds automatically, then you have to prove that the service is giving you an address that belongs to that person, and that's a bunch more math and everything else. But if you're just talking to someone and you say, "Hey, I want to pay you," and they respond directly, they can sign that response and say, "This address belongs to me," and prove everything in that step. Or they can send you the best way, I think, is just for them to send you a payment request, like say, "Hey, I want you to pay me this much," and then you know that that's their address, and you know that they're the one asking, and you're not going to accidentally send it to the wrong place, and everything's going to be signed and secured with some identity keys that you know about, and it's just way better.
That sounds great, doesn't it? Sounds great. Yeah, I love that. It also allows for things like schedule payments. And then you have a schedule for when you get a payment request for some subscription or whatever. So yeah, I think there's loads of possibility for that in the future. But it's a little off topic, but we should have another casual chat about that sort of thing at some point too. Any more questions from anyone who's listening in the cloisters? Otherwise, happy to call that a wrap.
I guess I have one last question. So just from a conceptual standpoint, there's this famous saying, "You can't predict the jazz of the future." So is it just an implicit, inherent, accepted aspect, I guess, of ARC's design, that you obviously, in the same way that you can't predict the jazz of the future, you also can't predict the miner of the future? And so is there anything with respect to not ARC not being aware of which future miners may need to have information that potentially that a transaction broadcaster would want that miner to know, but ARC doesn't know that miner should know about it yet? And can you maybe talk through conceptually like what that looks like with the design?
Well, I must be honest, I totally lost what the question was there. I think maybe your first sentiment is where my brain hooked on, and it was like, okay, yeah, guessing the jazz of the future. So I'll respond to that point. So I hope not, because I hope that, I mean, part of my job is trying to surface these early stage development things that are happening in Terranode, and attempting to prepare the ecosystem for what's to come in terms of, all of a sudden you don't have a JSON RPC. You can't just query a node and ask it for some data back. That was not something we knew was going to be a thing until maybe the more recent years. And so as I hear things in internal discussions about Terranode updates, and I'm so thankful that they're now pretty much public, we try and build systems, open source functional components that are able to cater to the needs of application developers while considering the trajectory that we know that the center of the network is going in, so we can try and keep ahead of that development. And Arc is just one element of that that was quite early in terms of building this component that helps people recognize that things are going to need to change so that we can build a more scalable network. And although the protocol doesn't change at all, the systems that wrap around that protocol kind of need to update with the huge difference in the amount of data that they have to process. We need to be more efficient than we ever have been before. It really just hasn't been a concern until recent times. Hopefully that answers your question.
Yeah, but maybe let me rephrase it a tiny bit. So let's just say that there's a new node on the network that is about to build, an ungodly amount of blocks in a row or something like this, but it hasn't yet started building that. So building those. So if a query or if a transaction was broadcast to Arc wouldn't necessarily know that this, future node would also need to know, or it would need to get some information about whether or not the transaction has been accepted by this future node, because the node hasn't started building blocks yet. It's about to. So I guess I'm asking, Arc is only giving information about nodes that it's aware of and whether they've accepted transactions, but it has no way of giving any information about nodes that it's not yet aware of. And is that, is there just an implicit problem with the design that maybe we just have to accept because it's the best we have so far, but it's that we can only get information about the likelihood of a transaction being broadcast with the assumption that the nodes that have already built blocks will continue to build blocks, and that if, for whatever reason, it just so happened that the transaction came in at the exact moment that, that this new miner emerged, whose proof of work was so great that basically, that miner just was the only one that produced blocks from that point forward, that the information would be it would be asynchronous. Does that make sense?
Yeah, I guess what you're saying is if the miner that is associated with the Arc instance that you're submitting transactions to is suddenly irrelevant because of the introduction of some new sort of, for example, a BTC miner that just suddenly moves all of its hash onto BSV, that would be kind of extreme. We're definitely vulnerable to that in the short term. I guess more generally, not just Arc, but the network as a whole is a little bit vulnerable in that if someone suddenly turned all of their hash power to BSV, that they wouldn't be competing with a tremendous amount. It's something that we considered in the sort of war room scenarios that we did last time we were in Switzerland together in terms of the BSVA. When the board came and spoke to us technical people, we ran through scenarios that could definitely happen. The defense mechanism that is being built into Terranode for that sort of thing is this idea that, honest miners don't suddenly announce, a 100 blocks simultaneously. And also with the subtree announcements, it's just kind of obvious when somebody announces a block where you don't know any of the subtrees, that it's somewhat dishonest behavior and that they've intentionally been hiding those from you so that it's more difficult for you to validate them. Things like that. So
yeah, well, in this assumption or in this hypothetical that I'm describing, the new node that's coming on the network is an honest miner, right? They're not trying to ignore blocks. They're looking to grab, the transactions and then put them into blocks. But I guess what I'm trying to say is that Arc can't give you information about the potential acceptance of a block from a miner that it's not yet aware of. But assuming that this node came on and then started to build blocks, then Arc would just say, oh, it looks like this is another network participant that we should be making sure, like when people send us transactions that we're getting basically that they're being accepted by this node. Is that kind of how it works?
Yeah, so if you imagine that if Arc were to be configured to have multiple peers set up, and one of those peers was just happened to be that new miner or whatever, then yes, it would get all of the peer-to-peer messages from that node and could listen out for seen on network messages to at least understand that, like Curtis was saying, that it at least has propagated and is propagating that transaction. So it wouldn't do that if it had a sort of competing spend of the same UTXOs, because the second one it saw, assuming it was an honest miner, would not be valid as far as it was concerned, so it would not announce it.
Yeah. Okay. Gotcha. Sorry if I am asking the basic question. I'm
Not at all.
not ashamed
Not
to
at all.
ask the most basic ones, but yeah, I just
That
wanted
was
to double check I understood it.
yeah,
I think,
definitely
Brett,
not a basic question.
another aspect to your question is simply if your Arc instance has been broadcasting the transactions to all the nodes it knows about, and then new Jazz comes along, I'm correct in saying, right, Dagan, that if the Arc instance doesn't see that transaction being mined, it's going to rebroadcast it across the peer-to-peer network, and therefore the new miners would see it at a later point, correct?
I don't know if I understand what you're saying. Sorry, David. Can you repeat the sequence of events you're trying to validate there?
In Brett's example of new miners with lots of new honest miners with lots of hash pop on the network, but that's after your transaction has already been kind of broadcast and propagated to all the nodes that were on the network previously. If that transaction doesn't end up being mined, Arc will still rebroadcast it across the peer-to-peer network in the future once it hasn't been mined after a certain period of time, and therefore the new miner will receive the transaction, correct?
It will indeed. Yes, correct. Thank you for taking the time to restate that. Yes, absolutely, it will. Yeah, that's basically the benefit of using Arc, is that the first thing it does when you submit a transaction to it is it stores it in this microservice called Metamorph. And it has it there, and it will rebroadcast it until it gets the appropriate responses. So it kind of, some people, most people would have built this into their application stack previously, and now they can kind of hopefully outsource that complexity to Arc, or they could run their own Arc instance, and then it would still be them solving the problem, but at least it's sort of containerized into its own sort of problem area.
Okay, thanks. And as usual, David rephrased my question in a way that made much more sense than when I originally explained it, to the point where I actually understand my own question better having listened to David ask it than how it was in my head.
You got a very creative question style, Brett. That's why we love you.
Yeah, but I guess I get now the concept, because previously it was just a gap. I didn't really understand that, but so Arc itself, once you broadcast to Arc, that's the point of you forget about it, because now if it doesn't get mined, Arc sort of waits around, and then and then Arc says like, hey, what's going on with this transaction? Does everyone have this transaction? And
exactly.
Assuming that new miner came on, maybe it didn't have that transaction, but not for a dishonest reason. It just didn't come on until after that was broadcast. So Arc sort of does the legwork for the person trying to broadcast the transaction and saying, okay, I didn't see this one get get mined yet. I'm gonna just shout it again. Does everyone that's building blocks have this? And in that case, it, like what David's question was, if someone didn't have it, but it was for an honest reason, they can just go, oh no, I didn't have that one. Let me grab it and I'll put it into the next block. And so in a way, I guess this goes back to just the concept of, okay, ARC's giving a response back to the person who broadcast the transaction, but the response isn't necessarily miner specific, right? Because it could be a future miner that ends up putting that into a block, and ARC didn't know about that node yet, and the node didn't know about the transaction yet. But at the end of the day, it's still the same result of the transaction should be accepted now because ARC has the basically does the legwork to make sure that it will get rebroadcast even if it doesn't arrive in a block in a sufficient enough time or something.
Yes, right, exactly. Yeah, ARC isn't a miner. ARC instances are being run by both of the main BSV miners, of course, but it isn't in and of itself a miner. It just listens to the P2P network, and so can give you sort of insights as to what the peers on the network think about this particular transaction.
Okay, so
if
sorry to ask
anything,
one more sort of question that is more geared towards a basic and a beginner, but then and maybe I'm sorry if you've already answered this, but would that mean then if I try to send a double spend to ARC, does ARC just ignore, like, doesn't try to broadcast the double spend because it already has broadcast the original spend? Does that make sense? Or does it still broadcast the double spend and assume that it's the miner that will ignore it?
Hey, that's actually a really good question. That's kind of nuanced. And I must admit that I don't actually know whether it's ARC that would reject it or the node. My assumption, without actually checking the code myself, I would have to double check this though, is that ARC will see that transaction is already stored in Metamorph, as in it will see that there is a transaction stored in Metamorph that's spending that UTXO. No, I don't think it's built like that.
I don't
think that's
believe it actually has any UTXO concept at all. I believe that's
it doesn't. It doesn't have the UTXO lookup. The reason I'm thinking that is because the original design included a UTXO lookup within ARC, and then that design was just used in Terranode, and everybody kind of moved on.
Because in the scenario that I just described, it actually could get double spent, because if the miner, it's an honest miner that came on the network, didn't know about the old transaction, but then ARC is still broadcasting the double spend, even though it thinks that the other miners won't mine it because they don't know, because ARC assumes that the other miners know that they've seen the first transaction, but actually the new miner never saw the first transaction, so it comes along and it sees the second one, and it says, okay, I will mine this, and now it's just double spent the rest of the network, and then the original instance saying that this would be mined is actually invalidated.
Yeah, I think you're actually right. Yeah, I think that would create a double spend scenario.
To clarify one thing on that, though, that ARC's main conduit to the network, I believe, is a. You know what? I might be wrong, so maybe I won't clarify that. Never mind.
I've had a few moments like that over the last 5 minutes. Yeah. So I guess to answer it in terms of how it would get rejected in the previous scenario, so long as there wasn't some other miner that just happened to join exactly at the worst moment, would be the first node that it sends the transaction to over the peer-to-peer network from ARC to that node would send a reject message in response, and we would get a reject response to the ARC. So assuming it hears both transactions, that's how double spends get rejected. And I have personally tried that, and it does in fact work. So
then
and it's part of the testing suite. So.
Wouldn't rebroadcast the one that one of the nodes on the network is saying it's a double spend, right?
No. You're right. If they join afterwards, so if somebody joins in between the announcements of a TX and the sending of that transaction data, then somebody suddenly joins, and there's a competing transaction that somehow gets sent to them but not others, then they would announce it as if it were valid. They would send to all peers, and all the peers would send a reject message to that peer. So if that peer mines a block before it gets rejected messages from the counterparties, then there's a small possibility that it creates a block that spends that transaction and invalidates the previous one. But certainly that would be bad behavior and a result of like bizarre situation that is improbable.
I'm sorry to drag this out because I know it's a hypothetical and it really doesn't probably bear any significance on an actual event that could occur. But wouldn't that be forcing that new node that just joined the network to like trust the other nodes on the network? So it's saying, I see this as a valid transaction, I'm going to try to mine it. The other nodes are saying, we've already rejected that transaction. But since the new node isn't aware of why that transaction was rejected, or would the information that the rejection that was being passed back by the other nodes, would it include some extended format transaction data to say this is why we've seen this one first? Because the only thing I'm thinking is, even though it's a complete hypothetical scenario, but that could create a true chain split, because the new node on the network that has a hash majority would be like, well, I don't know why these nodes on these minority nodes are telling me that this is an invalid transaction. To me, it's valid, and if they think it's invalid, they should compete with me on hash power.
Yeah, looking it up just now because there's documentation on this stuff. So,
To clarify that though, Brett, like you can't count on finality. I mean, Bitcoin is a probabilistic system. So at any point that there are competing spends going around and they haven't been mined yet, you can't be sure until they get mined and then get sufficiently deep what the head is. Arc doesn't actually change the mining process at all. It's really just about how the transactions get to the nodes. The consensus level of what is a double spend and what is like that doesn't change due to Arc in any way.
Okay, yeah.
yeah. So it is more of a question for the SV node developers at the moment in terms of how exactly that would respond. I have to look up some stuff to just find what message you can put in a reject message. So, for example, there are a couple of rejection codes. Block is invalid for some reason, invalid proof of work, invalid signature. Block's version is no longer supported, inconsistent with compiled in checkpoint. So you can state reasons, but it's one byte by the looks of things. So there would have to be a defined byte that means the transaction is rejected. Well, there's one here. So 42, for example, 42 in hex is transaction does not have enough fee priority to be relayed or mined. So that's one rejection message that's possible. 1, 2, or 12, or 18 in decimal is an input is already spent. So there is a specific code that says why, and then I guess it doesn't look like there's anywhere to put the TX ID of the competing transaction. If there was a way to do that, then you could basically the joining miner would then need to grab that transaction and validate that for themselves. But since it had seen the other one previously, I'm not sure that would affect its behavior. But the point is, there is a way on the peer-to-peer network to be informed of a transaction being explicitly rejected for the reason of a double spend. So it is there in the wire protocol.
Understood. Okay. And then theoretically, if the node again that joined was honest, it could say, "Oh, this is a double spend. I didn't realize why. Can you please it could make a request for getting the transaction separately in a separate channel or something?"
That's a good question. I don't know what strategy would be best. You could request the input transactions. You'd already have that. Nope, couldn't tell you. If I was that miner, I would just proceed as if they were wrong,
That's what I'm saying, and that could be a real chain fork, because now you have two honest miners who are not trying to.
Yeah,
Yeah.
I don't think it would be a chain fork. It would just be a case of the arcs of the other miners would, on that block being mined, and if they accept it, they would say, or perhaps they would reject the block actually. And once they reject the block, yeah, in fact they should reject the block. In which case that miner would then have a rejected block, get orphaned, and then they would be in a position where they need to decide whether to continue on their own fork. Yeah, you're right.
Yeah, it's just a race condition, and then basically, but neither one. So in a typical fork scenario like that, then one could just, the minority could just say, oh look, you know what, the majority was right about this or that or the other.
Or they just might strategically choose to throw out that transaction, given that there's a majority hash power. Yeah, it's possible. But yeah, Bitcoin, like David's saying, Bitcoin is a kind of rat's nest of complexity at that level. So yeah, it's all game theory and various different strategies and so on. Not a lot to do with ARC, especially given the trajectory we're going in. So there is an element of, yes, we know it's imperfect in these edge cases, but given that this is mainly to encourage people to keep SPV data around and pass that between counterparties, like that's one of the main drivers.
Okay, but just to be clear on the question itself, I'm broadcasting a transaction that's valid, and then a couple seconds later I broadcast a attempted double spend of my own transaction, and ARC would still propagate the double spend, right? Because it's assuming that it would be at the miner level that double spend would get rejected. Is that correct?
Yes, it would.
Okay. Otherwise, I think then ARC becomes like this de facto gateway point, because then if it's saying what is the double spend and what's not, then so I think it would have to propagate the double spend, Anyway, thanks very much for at least helping me understand that. It was fun.
Yeah, thanks, Brett. Suppose I better get back to it in that case. Thanks for all the questions. I appreciate your time, guys. Thanks for joining.
All right. Well, tune back in for another one of these sessions. We'll continue these monthly deep dives with our developer community. I'm your host, Manifestable, and thanks so much. We'll see you at the next one.